Hey guys, today I'm going to give you a brief history of cosmology from Big Bang until inflation. I inspired the title of this video from the famous book of Stephen Weinberg, of Stephen Hawking, Brief History of Time from Big Bang until Black Holes. It's a really interesting book. I strongly recommend you to read this book. You will learn a lot of things about the cosmology and the universe, and it's a public book, so it's easy to follow and to understand the concepts within it if you are not a physicist. Anyway, now for our video. In this video, I'll cover two long period of time of the age of the universe. You know, the age of the universe is around 13.6 billion years, and in this video, I cover around 10 to minus 34 seconds of the age of the universe. Oops, it's really too short time. I know that, but believe me, it's the most important period of the time, of the age of the universe. So please, in this video, I cover a lot of ground and I need all your attention. So please lend me an ear and listen carefully to each word I say. Let's start this video by an essential question. If I give you a brief history of cosmology, let me ask you at first, what is cosmology? What's the cosmology? What does the cosmologist study? A cosmology is a branch of physics which study the evolution of the universe from beginning until the end. But to be honest with you, as cosmologists, we more concentrate sometimes we completely concentrate on the period from the beginning of the universe until the present, because for this period we have a lot of experiments, satellites, WMAP, Bicep 2, and a lot of experiments which can give us statistical data, and this data can help us to evaluate our theories and the validity of the theories and the model of the universe. But we don't have like this ability when it comes to the end of the universe. So in principle, the cosmology is a branch of physics which deal with the evolution of the universe from the beginning until the present. Now the second question which I want to ask, if the cosmology is a branch of physics which study the evolution of the universe, what is the universe? When I say the beginning of the universe, what I meant? What the meaning of the beginning of the universe? Is that the beginning of the earth? Is that mean the beginning of the humankind? Is that mean the beginning of our galaxy? Is that mean the beginning of the galaxy around us? What do we mean when we talk about the universe? Actually, when we talk about the universe, we talk about all of these things. We talk about the earth. The universe contains, the earth, the solar system, our galaxy, the galaxies around us, all of these galaxies, all of kinds of ordinary matter. I mean ordinary matter, the matter which constitute us, constitute the earth, the sun, the galaxies. So when we talk about the universe, we talk about the ordinary matter and more. And more? Is there anything else more? Yeah, actually there is what we can call it the light. There's the light. But in general we say, the light, it's invisible light. It's an invisible kind of electromagnetic waves. But we have a wide range of electromagnetic waves. Small part of this range is the visible light, but the other wavelengths, it's invisible, like the X-ray, gamma ray, and etc. And also we have what we call it a neutrino. A neutrino, it's teeny tiny, it's a really small particle, and sometimes we thought that it's have no mass, but then the oscillation of the neutrino show that no, this isn't right. And neutrino is move with high speed, the speed which close to the speed of the light at the vacuum. So this kind of the matter, usually we call it as relativistic matter. Relativistic matter, we mean the electromagnetic waves and neutrino, or the matter or particles which move in high speed, the speed which close to the speed of the light at the vacuum. Why relativistic? Because this is related, to the special theory of relativity. So anything move with high speed, the speed which close to the speed of the light at the vacuum, we call it as relativistic. So keep in your mind, when we talk about the universe, we talk about ordinary matter, we talk about relativistic matter, and more. Really, and more. What there is other these. Actually, there is what we call it dark matter. Dark matter. What's the dark matter? The dark matter, it's unknown kind of matter. We know that it exists because we can observe the gravitational effects of this matter. But actually, we don't know what the real nature of this matter, what the reality of this matter. We have models, we have theories about this matter, but we don't have an ultimate and unique theory about the dark matter. And it's constituted around 25% of the component of the universe. So it exists. So when we talk about the universe, we talk about ordinary matter, relativistic matter, dark matter, and more. And more, yeah, because there is teeny tiny things what we call the dark energy. What's the dark energy? Dark energy is unknown kind of energy, so we call it dark. And it's the energy, it's responsible for the accelerated expansion of the universe. We'll talk about the expansion of the universe and the accelerated after some slides. So it's some kind of energy. For now, let's keep in mind that it's some kind of energy. It exists. Also, we don't have a unique and ultimate theory about this energy, and it's constituted around 74% of the energy of the universe. Oh, yeah, it's a huge, gigantic amount of energy. So when we talk about the universe, we talk about ordinary matter, relativistic matter, dark energy, and more. And more, yeah. There is really now, it's really teeny tiny things. I'm always feel so proud when I talk about that, and I say, yeah, as cosmologist, I study these two things. These two things is that space and time. Yes, guys. In cosmology, we study the beginning of the universe, and that equivalent the studying of the beginning of the space, the beginning of the time itself. So when we say that we study the beginning of the time, don't ask me about the moment before the beginning of the universe. Don't ask me about the moment before the beginning of the time. How can I tell you about the time before existence of the time? Okay, our mind, our thoughts is completely constrained at this beginning, constrained within the time, within the space. How can I imagine something beyond the space, beyond the time? Okay, I know that there is religious and there is some scientists or philosophers who talk about the things. We respect all things, but and there is no conflict between this and physics. All what I mean here, as a physicist, we cannot build a theory to describe the moments or the time before existence of the time. It's not science for us as a physicist. Okay. Now, so please, when we talk about the universe, we talk about all of the things. We don't mean by the universe, the things like galaxy, just the galaxies and the planets. No, we mean the time and space itself, and we mean that things which we don't know what the reality of things like the dark matter and dark energy. Now, also I want to mention about an annoying something for me as cosmologist. I want to talk about the difference between cosmology and astronomy. Always I meet people who told me, yeah, your study is really exciting as cosmologist. You spend your time and your nights looking at the telescope, looking at the sky, and observe the moon, and observe the planets and the galaxies and all of these interesting things. This is really incredible. Come on, guys, please. We don't study, we don't do that as cosmologists. That's the work of the astronomers, but not as cosmologists. And even in astronomy today, we don't work like that because there is satellites and there is statistical data. But anyway, this is not our work. As a cosmologist, we study the evolution of the universe. Believe me, we don't have telescopes. We never ever look at telescope. All what we can see always and always is tons of papers. And if we found ourselves run off out or empty papers, we'll forced to write on the wall, like in this case. I can't remember this story. It's happy and sad at the same time. It's happy because at that night I was working too late, and I was so excited to finish my work, but I found that I'm out of papers. So I'm so excited. I want to find the final equation, what the final results. So I first to write my equations on the wall. On the wall. Now the happy things is that I found the final results, and it was good work. But you know what? The sad things. Oh my God, it's a horrible story. At the next morning, when my wife wake up and saw me, hello honey, good morning, I missed you. Then he looked at the wall and said, what the hell, meaning of that? Why you were writing on the wall? Why you wrote on the wall? On the wall? Didn't you have a paper? Yeah, no, believe me, no. I'm just kidding. My wife is from the cool-headed. She looked at the wall and she smiled and laughed at that. She take it easy, even though she forced me to scrub the wall. And no, I don't want to complete. But please, if you met her at any time, don't tell her that I told you this story. Okay, let's keep it as a secret between us, please. Okay, guys, so now please differ between the astronomy and cosmology. Now I'm going to talk about the first thing and the math things, and actually the thing which make the cosmology as real science, as a real science. I cannot say anything else that. But for now, I stopped the video, and I saw this talking about this in the second part, so you can follow the part more easier, and to listen about the cosmology for 10 minutes, then another 10 minutes, then another 10 minutes. I think that's more helpful and more useful. So I stop here and I continue in another part. Thanks a lot for your listening and for your clicking. I hope that this is helpful and clear, and I will also